everyone. Welcome to our project presentation. Have you ever wondered why top talent suddenly leaves an organization? Today, we are diving deep into the analytics behind one of the most critical challenges in business, employee attrition. Employee attrition is reduction in the organizational workforce that occurs when employees leave, either voluntarily or involuntarily. High attrition leads to significant cost, loss of valuable talent, and can dampen the morale of remaining employees. For this project, we leveraged a publicly available and highly relevant dataset from Kaggle, IBM HR Analytics Attrition. This comprehensive dataset featuring 36 features including employee demographics, job details, work environments, job involvement, compensation, and most crucially, their attrition status. This dataset is perfectly suited for our analytical objectives. Our main goal was to build a robust classification model to accurately predict employee attrition. More than just predicting, we wanted to focus on three sections. Number one, proactively identify individuals with highest propensity for attrition. Number two, discover main reasons, hidden patterns driving the attrition means pinpointing the specific areas of concern where the company needs to improve. Number three, provide clear, data driven, actionable recommendations for the organization to address underlying issues, enhance employee satisfaction, ultimately foster a more stable workforce in future. For this project, we used KNIME Analytics Platform. Our initial steps involved importing raw data using CSV Reader, and we removed four irrelevant columns, setting the stage for further visual analysis.
Data visualization allowed us to understand and uncover hidden patterns, identify potential factors of attrition from our dataset. For categorical features, we utilized bar and pie charts, and for numerical features, scatterplot and boxplot were employed to reveal patterns and relationships. Features against attrition rate, we found significant insights. 1. Employees who work overtime have more attrition rate. 2. Employees with lower job involvement have more attrition rate. 3. Entry-level jobs showcases more attrition rate. 4. Unmarried employees have more attrition rate than married and divorced. 5. Poor work environment and low job satisfaction increase the attrition rate. 6. Employees who travel very frequently has more attrition rate. That is why sales representative department has highest attrition rate than other departments. By visualizing numerical features against attrition, we found significant insights. 1. Through scatterplot, we observed employees with young age and low to moderate monthly income has more attrition count. 2. Employees with fewer working years and lower monthly income have more count of attrition. By analyzing the box plots, we can conclude that 1. Employees with fewer years spent at company, fewer years under current manager, and fewer years in their current role demonstrated a higher rate of attrition. 2. More distance of organization from home reflected higher rate of attrition. Significant outlier present at total working year, years at company, and in current role. Factors such as gender, department, percentage of salary like contribute very minimal to attrition. Means they are not very important factors that causes attrition.
Proper data pre-processing is foundational for robust model performance. First, we handle our categorical features. Those are ordinal but non-binary, just like job level. We use one-to-many node for one-hot encoding, which transform each rank categories into separate binary column that ensure they are in a suitable numerical format. For numerical features with high variation, just like monthly income, we applied min-max scaling via normalization node. This transformed data to a 0-1 range, ensuring fair influence during model training. Target features attrition is converted to string. Then using partition node, we perform 70-30 training testing split. Means model were trained on the 70% of total data and evaluated on 30% of unseen data, providing an unbiased result of the real world performance. Data revealed a severe class imbalance, 84% no attrition, 16% attrition. This imbalance can bias model towards my majority class 0. To mitigate that and ensure accurate prediction of minority class, we applied the SMOT on our training data. SMOT is a synthetic minority oversampling technique which systematically generates new representative samples for the minority class 1 to balance the dataset for robust attrition. For our classification prediction, we selected three machine learning algorithms chosen for the suitability for our business goal. First, logistic regression. It predicts the probability of a binary outcome like attrition based on various input features, allows us to understand the linear relationship between attrition and input features. Second, random forest classifier. This ensemble learning technique combines multiple decision trees to improve predictive accuracy of the model. It is very good for capturing complex relationship within diverse dataset. Third, naive-Bayes algorithm. This probabilistic classifier based on the Bayes theorem assume independence between features to predict class probabilities.
After testing based on specific performance matrices, we have selected best two models. For this, we have used scorer node and ROC curve node in our KNIME workspace. For evaluating model performance, we use five metrics. Number one, precision. It is the proportion of predictions that were actually correct. Number two, recall. It is the proportion of actual positive cases that were correctly identified. Number three, F1 score. It is an indicator of how much model will predict correctly and how much predict incorrectly. It is the harmonic mean of precision and recall, balancing both the metrics. Number 4, AUC, area under ROC curve. It is the model's ability to distinguish between positive and negative classes. Number 5, accuracy, means overall proportion of current prediction, both for positive and negative classes. After analyzing the model performance, naive-Bayes classifier showed a superior ability to identify actual attrition with 91% recall. Conversely, random forest achieves the highest precision at 80%, means its prediction of attritions are often correct. Naive-Bayes classifier showed superior balance and discriminatory power through its highest F1 score of 72%. Shockingly, random forest F1 and recall values are below 50%. In terms of accuracy, naive-Bayes 89%, random forest 88%, and logistic regression has 82%. An ROC curve means receiver operating characteristics curve. It is a graph that shows a binary classifier's performance by plotting true positive rate against the false positive rate at various thresholds. The AUC indicates overall discriminatory performance. Higher AOC value means more clear distinguish between 0 and 1. In our project, there are three models and all of are performed in AUC level 0.8 above, but naive bias has the highest AUC 0.9. Based on our performance metrics, we need to select models which has not only highest accuracy rate but also high recall, precision and F1 measure. So for this, prioritizing the ability to identify actual actions, we select naive-Bayes classifier model and logistic regression model as our two best models, despite random forest classifier has high accuracy. So, in conclusion, our project successfully developed a robust classification framework using naive-Bayes and logistic regression to proactively identify employees at high risk of attrition. Factors like overtime work, lower job satisfaction, specific job role, frequency of travel, years with current manager are directly triggered the attrition rate. These insights empower HR to implement specific strategies like reviewing overtime, enhancing engagement programs, and taking special care of specific departments to retain valuable talents and preserve institutional knowledge. There are several limitations in our model. Our model is totally trained on historical IBM data, so result may not accurate and generalize across all industries. For future improvements, we could include more recent data, incorporating employee feedback surveys, or explore advanced deep learning techniques. Ultimately, this project fosters a data driven strategy for more stable, engaged, and productive workforce. And that concludes our project presentation. We truly appreciate your attention and interest in our work. Thanks for watching.
Hi, I'm Shosvik Shamandar.
Hi, I'm Etana Goswami.
Hi, I am Nilima Gupta.
Hi, I'm Sobi Chatterjee. I would like to thank Professor Dr. Kaushik Dutta sir for teaching us such valuable knowledge and lessons about machine learning.
I would like to thank IIM Kolkata Center for Leadership and Ethics for organizing such an insightful workshop for us.
I would like to thank all my teammates for giving their best in this project.
We always welcome any type of further suggestion in betterment of our project because learning is our paramount objective. Thank you.